which is Coline Bichlmaier from Munich. Hello. From the group of Roman Lang, and Coline is actually making an exciting talk on a newly identified pyrolysis product, which is a social.
So now we are seeing both mass spectra. And here you can see what I said before, the difference of 18 Dalton, which indicates a water loss in this precursor structure of Mozambioside. And we have one position where this water cleavage can happen. And this is the position 16. You can see it on the structure of Mozambioside. But to verify this assumption, we have to also look at the NMR spectrum. So here you can see the HSQC spectrum on the left-hand side of Mozambioside, which shows the signals which are triggered by carbon and directly connected proton atoms. So highlighted in orange, you can see the typical signals for the glucose moiety. In green, you can see the hydroxylated carbons, and in blue, you can see the furan protons. And when you look at the right-hand side, which is the spectrum of roasting product 5, you can also see the typical signals for the glucose moiety, the hydroxylated carbons, and the furan protons. And when you look at the structure of Mozambioside, unfortunately I have no pointer, but at position 15 there is a methylene group. And on the left-hand side in the spectrum, there were no signals for this methylene group on position 15. But a new signal appeared here, shifted to the left, indicating a CH group. And since we knew, okay, there was a water cleave-off at position 16, and there has to be a double bond formation. Now we know where the double bond formation was formed. So it was between 15 and 16. So this was very short. This looks so very, very easy, but it was a long, long way to identify all of our 6 newly appeared roasting products in our UHPLC-PDA chromatogram, and 5 of them, so 2 to 6, were newly identified. 7 was the already known bengalensol, so this was already identified as a roasting product in Arabica coffee. You can see also the structure of number 8. This was synthesized by enzymatic cleavage, and you can see that this represents the skeleton of all of our roasting products and Mozambioside. So we synthesized the structure just to do some structure-related activity experiments. And after we knew the structure of all of our roasting products, we wanted to know if they still activate the human bitter taste receptors. And they do. When you look at the bitter threshold of 4, 5, and 6, okay, this is a little bit shifted downwards, so the box should include 4, 5, and 6. Then the bitter threshold is lower compared to Mozambioside. And even the deglycosylated products, which is 7 and 8, so where the glucose was cleaved off, are even more potent activating the human bitter taste receptors, even compared to 4, 5, and 6. So now we knew the needed concentration in vitro to activate our human bitter taste receptors. And subsequently, we wanted also to know which amounts we can expect in authentic coffee samples. So we developed a quantitative Q-trap MS method and tuned 1 to 8 for this method. We synthesized an internal standard, which is depicted here with number 9, and validated this method. So our first package of samples were roasting series. Here you can see time and temperature dependent roasting series with the degradation of 1, which is Mozambioside, and the formation of our high potent bitter receptor activating roasting products 4, 5, 6, and 7. And at industrial-like parameters, you can expect the highest possible concentration of 4, 5, and 6, and even roasting product number 7. And of course, we did not end with just roasting series. We also wanted to know the concentrations in authentic coffee grounds, which we can buy in a grocery or the supermarket. So here you can see the concentrations from the minimum to the maximum. It is a very huge difference between different samples. But when you look at the left, on the right corner on the top, you can see the UHPLC-PDA chromatogram I showed you before from the model roasting approach. And when you look at the ratio of our roasting products in the model approach and look at the ratio of our content in authentic coffee grounds, then it looks very similar. So our model roasting is very good in representing the ready and consumable authentic coffee grounds. And you may think, yeah, okay, very interesting, but we do not eat the bean. Yeah, that's right. We also wanted to know the extraction rate. And for Mozambioside and the roasting products 4, 5, and 6, we could find extraction rates from about 65 to 110% into our beverage, which is consumed by all of us, of course, who drink coffee. So maybe you will remember the next time you drink an Arabica coffee, the amount and our roasting products which you are consumed. So to sum it up, we found 5 new roasting products formed from Mozambioside during the roasting process, and 7 was the already known bengalensol. We've also found out that they activate the bitter taste receptors TAS2R43 and 46 with an even lower bitter threshold compared to Mozambioside, which means that they are activating the 2 human bitter taste receptors even more potent compared to caffeine. And last but not least, do they contribute to the bitter taste of coffee? Yeah, that's a good question, because we have in vitro data and concentrations in coffee grounds and in coffee brews. And here you can see different extraction methods. So we compared filter brewing method with Turkish, with French press, with cold brew, and with espresso method. And the fascinating thing was that only with harsh conditions and with a higher concentrated amount of the coffee matrix with the espresso brew, which was brewed by mocha pot, we can find the roasting product 7 in our brew. And the dotted lines, the dashed lines are showing the lowest bitter threshold for roasting product 7 and 6. And as you can see, only roasting product 7 reaches the lowest bitter threshold, which was determined in vitro. So with the espresso brew, we can expect a contribution from roasting product 7 to the bitterness of coffee. But these are data, these are calculations, and the bitter thresholds are done in vitro. And when you remember the first graph I showed you in the second slide, then Dr. Roman Lang showed that the unroasted approach of Mozambioside was tasting less bitter compared to the roasted approach. And currently, we are doing some 3 AFC analysis with a human sensory panel for all of our bitter receptor activating roasting products to evaluate the in vivo bitter threshold and to compare our human bitter threshold with the in vitro model. So, and last but not least, I will say that bitter compounds and especially diterpenes, we've already heard it yesterday, are known for health beneficial, for being health beneficial. So we will also go into this direction, so you can think maybe think what's in our pipeline for the next few months, maybe years. And yeah, so maybe I will present you the next time our newest data. So stay tuned. Thank you for your attention, and I will thank also my mentor, my supervisor, my work group leader, my colleagues, and my friends and the LSP, and you, of course, that I have the opportunity to be here today. Thank you so much.